Here we're going to talk about the chapter equilibrium. We find whenever we talk about reactions, they could be classified into two categories. The categorizations are as follows. The first kind of reaction is static reaction, where we find the reactants get transformed into products. The other kind of reactions are dynamic reactions, where the reactants get transformed into products, but they are reversible in nature. This is how we represent the reversible reactions. The example of reversible reactions are something that we find in the habers process and the context process, and both the processes are very important from the exam's perspective. We will be talking about the conditions very soon. On the other hand, we find there are various kinds of reactions, like the neutralization reaction is also kind of static reaction which does not repeat itself. So hydrochloric acid, when combined with sodium hydroxide, this is a neutralization reaction that I'm talking. It results in the making up of sodium chloride and water. These reactions are one-time reaction happening in one direction, where this is a reversible reaction. Now the most important thing, the next thing, is the definition of dynamic equilibrium. So understand what is dynamic equilibrium. Dynamic equilibrium definition is as follows. We find that there are reactions which are, if reactants is getting transformed, if reactant getting transformed into products, that's forward reaction, and if product is getting transformed into reactant, that's backward reaction. So you find the reaction in which the rate of forward reaction equals the rate of backward reaction, that is called as dynamic equilibrium. Reaction in which rate of forward reaction equals rate of backward reaction. As simple as that. So we find that if you find all of these reactions which are there of reversible nature, we find that these reactions aren't that much effective, because I will give you one example of a reversible reaction where nitrogen is reacting with hydrogen to give you ammonia. Now what was the problem with this reaction? That whenever they were getting ammonia, they were also getting, because it is a reversible reaction, they were getting transformed back into their reactant form, and it was a huge loss to the company who were doing this kind of reaction. As far as ammonia is concerned, we know that it has a huge use in the field of explosive making, in the field of making bombs, and these pages are moving, and fertilizers. All right, so we find that ammonia is really important process, but it is a problem in getting ammonia, since it is a reversible reaction. So how to make this reversible reaction happen? We come across a very important rule which is called as Chateliers Principle. Chateliers Principle. So Chateliers Principle states that in a reaction at equilibrium, if a change is made in its condition, then equilibrium is broken down. Then the equilibrium no more exists. Then equilibrium is broken down, and the system opposes the change and tries to reset the equilibrium. System opposes the change and tries to reset the equilibrium. What was the intention? See, actually what happens, if you see this nitrogen and 3 hydrogen and this ammonia formation, see, this is a reversible reaction. We want maximum of the product, Okay, and we want minimum of our reactant. We don't want the reactant to be there, but since it is a reversible reaction, and since when it becomes equilibrium, the forward and backward reaction will be equal, so reactants are always going to stay. They are not going to completely get transformed into product. So in order to have maximum amount of product, this thing technically in equilibrium you also call it that you want to shift your equilibrium towards right, because this is the right hand side, na? Product is put on the right hand side, so shift equilibrium towards right. So how can you shift equilibrium towards right? You can shift equilibrium towards right by breaking the equilibrium and give certain conditions here. Give it certain condition such that it will reset the equilibrium. You will again get the equilibrium, but this time you will be having more amount of your ammonia, the product in which you are interested. So what we find, there are certain conditions that we need to talk about. So in chemistry, whenever we talk about condition means three things. The first thing is temperature. And the second thing is pressure. And the third thing in chemistry is the catalyst. So temperature, pressure and catalyst are the three important conditions. So here I'm on the second page now. And so when we talk about temperature could be classified. See, reactions can have two kinds of requirement. Reactions could be exothermic or it could be endothermic, exo or endo. Now because of being of different nature, they have different requirements. So first of all, we are going to talk about the exothermic reactions. Exothermic reactions, when we talk about, now this is a reaction which is going to give you energy. Exothermic means something that releases, that gives energy out. So in this case, since this is giving energy, see, low temperature is never recommended for such kind of reactions. Low temperature is not recommended. Okay, so since low temperature is not recommended, why? The reason is since it does not have sufficient kinetic energy for the reaction, because you need to provide sufficient kinetic energy for the reaction. It is not giving sufficient amount of kinetic energy. So that's the first point I want to say about the temperature. The second point that you need to know is that even high temperature is not recommended. What's the reason why high temperature is not recommended? High temperature is not recommended. The reason behind this is that ammonia is having structure like this, NHHH. So if you give very high amount of energy, these bonds will break, the products bond will break, and backward reaction will happen. So if you give very high temperature, it will break the product bond. It will break product bond and cause backward reaction. So are you interested in the backward reaction? No, we are not interested in the backward reaction. So this is the problem. Backward reaction is not recommended. Now the third thing, therefore moderate temperature is the best one. Moderate temperature is best. Okay, that's what I can say. Now talking about the second category of the temperature, which is an endothermic reaction. What is so special about endothermic reaction? Endothermic reaction is, see, again I would say that low temperature is not recommended because it is not recommended. Okay, why? Since no sufficient kinetic energy, K dot E. Okay, on the other hand, is high temperature good? So we find yes, high temperature is good. High temp is good. Why? This allows, because endothermic wants to have a lot amount of energy. So since you give lot amount of energy to it, so high temperature is recommended because it has sufficient, because it favors forward reaction. It favors forward reaction. That is it. Alright, so here I have spoken about the temperature. Now the second thing that I will be talking about is pressure. So the second point, we are talking about pressure. सो व्हाट हैपेंस इन टर्म्स ऑफ प्रेशर, प्रेशर में क्या होगा, देखो सबसे पहले मैं अगेन आई विल बी टॉकिंग अबाउट दिस सेम रिएक्शन, reacting with 3 hydrogen to give you 2 ammonia particles. So what exactly happens here, pressure में क्या होने वाला है, so we find देखो यहाँ पे ना 3 इसका और 1 इसका, टोटल देयर आर 4 moles of reactants और यहाँ पे 2 moles products के हैं, तो which one is having less, this one has lesser thing. So you know अगर तुम इस पे हाई, these all people are gas, तो अगर गैस को तुमने हाई प्रेशर दिया, so they will be squeezed and they want to move on the side which has less volume, means where they will feel comfortable. So only after reaction they will come in a comfortable zone, where high pressure means उनको squeeze करता है ना, space को कम करता है, तो space अगर कम करने जैसा तुम condition high pressure मारोगे तो वो घूम करके अमोनिया बन जाना पसंद करेगा. So we find that in this context high pressure is the best one. So I will write a technical statement over here that high pressure favors the side with less moles. High pressure favors the side with less moles. With less moles. That's it. Okay. And vice versa. Vice versa, I mean to say low pressure इसका opposite effect दिखाएगा. Low pressure मतलब low pressure will favor the side with high moles. That's it. So pressure हो गया. This is also over. Talking about the third thing, which is a catalyst. Catalyst क्या होता है, देखो catalyst is a substance that increases the rate of reaction. So substance that increases the rate of reaction, substance that increases ROR, rate of reaction, without affecting itself, without affecting itself, right? So ये तो catalyst हो गया. तो catalyst क्या करता है, catalyst is going to favor, so I can say it favors forward and also the backward reaction. तो दोनों reactions में ये तुम्हें help करेगा. तो जिसकी वजह से क्या होता है, therefore equilibrium is reached faster. Therefore equilibrium is reached faster. So is catalyst important? Yes, catalyst is also important. Equilibrium is reached faster. अच्छा, इन सब के बाद एक और इम्पॉर्टेंट पॉइंट आता है, फोर्थ पॉइंट, जिसकी वजह से तुम्हें प्रोडक्ट मिलने में ज़्यादा फेवर मिलता है, और वो पॉइंट है रिमूवल ऑफ द प्रोडक्ट. अगर प्रोडक्ट ही नहीं रहेगा तो इक्विलिब्रियम किस बात का, इक्विलिब्रियम रहेगा नहीं, फिर रिएक्टेंट विल बी गेटिंग ट्रांसफॉर्म, द रिमेनिंग रिएक्टेंट विल बी गेटिंग ट्रांसफॉर्म इनटू द न्यू प्रोडक्ट. सो रिमूवल ऑफ प्रोडक्ट इज ऑल्सो अ वे इन विच you can shift the equilibrium towards that, or you can get more and more products. Okay, so in this way I have spoken about all the 3 conditions. This is all that you have in this chapter. Now we'll be talking about examples. There are 2 examples in this chapter, which is Haber's process, and the second one is context process. So just understand what are these things. So Haber's process तो ज़्यादा कुछ है नहीं, सिर्फ Haber's process के conditions बहुत important हैं. मैं दोनों की conditions यहाँ पे लिखता हूँ, Haber's process, और इस तरफ लिखता हूँ contacts process. Contacts process. So सबसे पहले हम बात करेंगे टेम्परेचर की, दूसरी हम बात करेंगे प्रेशर की, और तीसरी हम बात करेंगे कैटलिस्ट की. किन दोनों रिएक्शन कौन सा कैटलिस्ट, तुम्हें मालूम होगा कि अमोनिया के फॉर्मेशन में हेबर्स प्रोसेस, तो ये है NH3 मेकिंग प्रोसेस, और ये है H2SO4 मेकिंग प्रोसेस. ठीक है. सो टेम्परेचर यहाँ पे कितना लगेगा, 450 डिग्री सेल्सियस, यहाँ पे कितना लगेगा, 450 डिग्री सेल्सियस. प्रेशर यहाँ पे कितना लगेगा, 200 ATM, यहाँ पे कितना प्रेशर लग रहा है, 2 ATM. कैटलिस्ट यहाँ पे क्या है, यहाँ का कैटलिस्ट आयन है, यहाँ का कैटलिस्ट क्या है, V2O5, जिसे हम लोग क्या बोलते हैं, वेनेडियम 5 ऑक्साइड. तो इस तरीके से हमने इसे देख लिया. दैट इज इट. ओके, सो ये कंडीशंस बहुत इंपॉर्टेंट होते हैं, तो मैंने कंडीशंस यहाँ पे बता दिए हैं, ये कंडीशंस दिमाग में रखो अपने. और अब हम चलते हैं हेबर्स प्रोसेस का रिएक्शन, जो मैं काफ़ी रिपीट करते हैं. सो अगेन आई विल जस्ट रिपीट माई सेल्फ, दैट इज गोइंग टू गिव यू नाइट्रोजन प्लस 3 हाइड्रोजन रिजल्टिंग द मेकिंग ऑफ 2 अमोनिया. दैट इज इट. अब हम बात करेंगे कॉन्टैक्ट प्रोसेस के बारे में. कॉन्टैक्ट प्रोसेस में बस तुम्हें 4 रिएक्शंस याद रखने हैं. क्या हैं वो 4 रिएक्शंस? नंबर 1, 4 reactions. There are 4 reactions and 4 step reaction, I would say. What are they? The first one is sulfur combines with oxygen to give you sulfur dioxide. दूसरा, अब ये जो सल्फर डाइऑक्साइड है, अब ये आगे चलेगा. सल्फर डाइऑक्साइड comes in contact with oxygen once again, and ये है मेरा रिवर्सिबल रिएक्शन, जहाँ पे सारे के सारे कंडीशंस अब यहीं पे आके अप्लाई करोगे अपने. फिर तीसरा आएगा, ये सल्फर डाइऑक्साइड किसके साथ रिएक्ट होने वाला है, द सल्फर ट्राइऑक्साइड इज गोइंग टू कंबाइन विथ सल्फ्यूरिक एसिड। वाटर नहीं यूज़ कर सकते हम क्योंकि बहुत ही एक्सोथर्मिक हो जाता है, एक अनकंट्रोलेबल एक्सोथर्मिक रिएक्शन होता है जिसमें फ्यूम्स बनते हैं और सल्फ्यूरिक एसिड को कंडेंस कर पाना भी काफ़ी टाइम कंज्यूमिंग प्रोसेस है। इसलिए सल्फर ट्राइऑक्साइड में सीधा सल्फ्यूरिक एसिड जब ऐड करते हैं तो यहाँ पे एक एडिशन रिएक्शन होता है, H2SO7 सब्सटेंस फॉर्म होता है जो कि एक लिक्विड है जिसको हम ओलियम भी बुलाते हैं। तो ओलियम इज द थिंग विच इज मिक्सड विद वाटर एक्चुअली, और फिर जितना भी तुमने सल्फ्यूरिक एसिड दिया था वो तुम्हें वापस मिल जाता है, ये देखो ऐसा H2SO4 के फॉर्म में। ठीक है, तो इस तरीके से हमने सल्फ्यूरिक एसिड मेकिंग प्रोसेस भी देख लिया। अच्छा, अगर मैं बात करूं कि कॉन्टैक्ट सल्फ्यूरिक एसिड का यूज क्या है, तो यूज क्या है, इट्स यूज इन पेपर इंडस्ट्री, इट्स यूज इन डाई इंडस्ट्री एंड इट्स यूज इन पेपर इंडस्ट्री में यूज होता है, डाई इंडस्ट्री में यूज होता है, बैटरी मेकिंग में यूज होता है। तो ये कुछ इसके यूजेस हो गए। ठीक है, सो इन दिस वे दिस चैप्टर इज ओवर, बाय बाय।